All right, welcome to our last notes of pre-calculus this year. What a way to end the year from where we started. But we still have, as I mentioned, you're still gonna have a final exam. Again, if you haven't looked at that, please go and review that. Let me know what questions you have, because it's really important that you all understand that, because it's still worth 10% of your final grade, and you'll have a couple of places that you can work on that final grade, but you're only going to know that information if you go and you find it or you ask me or anything like that. So, binomial theorem, hopefully some of you remember this from previous years. It's going to start off with being based in combinations, and so we're going to review what that is first. So if you remember combinations, so this is the idea, we read this as n choose k. On the calculator it might look like this. And it's written like a sort of like a fraction in parentheses, but there's no line in the middle. It's just two numbers over each other like this. And it's equal to n factorial, so that numerator, over k factorial times n minus k factorial. And what it is it's the number of ways that something can happen, right? It's a measurement of how many ways can we choose k objects from n total. You can totally do this on your calculator. I want you to be able to do it by hand as well. If you're using any of the TIs, the most likely way to do this on your calculator is you're going to go to math and then probability, and you're going to see something like this as an option. You can pick that. Make sure you put the first number first. So if I wanted to do A on a calculator, I'd do 8, and then that button, click in there, and then 2. If you don't know how to do it on your calculator, I recommend you Google it, or I can help you Google it. Let's work at how to do it by hand. So if we've got here, we read this as 8 choose 2, and we can just plug this into our formula here, where we see that 8 is our n, and 2 is our k. So this tells us the number of ways to make a pair, to choose 2, out of a sample set of 8. So in this case, it's 8 factorial over 2 factorial times, and then n minus k. So 8 minus 2 factorial. Now, remember, factorials are those expanded multiplication problems. So this is 1 times 2 times dot all the way out to 6 times 7 times 8. That's what 8 factorial is. I'm skipping some numbers in there. 2 factorial would be 1 times 2. We're still following an order of operations, so parentheses before multiplication. So 8 minus 2 is 6. So then that's 6 factorial, 1 times 2 times dot 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 out to 6. Now the nice thing about factorials and combinations is that this number is super big. Obviously this number is super big, but we can do a lot of canceling. The 1 through 6 on both we can cancel. Then we've got just 7 times 8 over 2. Cancel that to 4. And now you're just looking at the problem 7 times 4, which is 28. So it's nice to be able to do it on a calculator. It's also important to be able to do things by hand as well. So with B, you'll notice that there's a 0 in the denominator, which creates, in quote-unquote the denominator, which creates what some of you would cause some panic at. If I've got 18 factorial then over 0 factorial, and then 18 minus 0 factorial, you might freak out and be like, oh no, there's a 0 in the denominator. This is one of those weird things with factorials. 0 factorial, as some of you might remember, equals 1. And so it looks like there's a 0 in the denominator. You can evaluate it and simplify it and just plug in 1. So then this is 1 times 18 factorial in the denominator, and then 18 factorial in the numerator. Those are going to cancel, and you're just left with 1. So I always like to review this really quick here. So what some of you might remember about binomial expansion, and remember a binomial is just 2 terms, and an expansion is 1 to that power, is Pascal's triangle. And this is where you create that triangle by adding the 2 numbers above. So we start off with 1, 1, 1, add those 2 numbers, we get 2, 1, 1, 1, 1 plus 2 like this is 3. Again, another 3. And so on. You might have made a big one of these as a young child, and so on. And these are the coefficients of these expansion, depending on the row. So, right, quadratic, we've got our degree 2, cubic, which we used in our last notes. Here would be degree 4, so that's what we're going to use for this one. Now, if we were just going to use A and B, we can see what this would expand out to with these coefficients. So here we can see that we've got our coefficients, 1, 4, 6, 4, 1. We start with our A to the 4th here, count down with our A powers, then up with the B's so that each term still has a total degree of 4. And this would be the expansion A plus B to the n. Now here, we don't have A and B. We have 2x and we have y squared. But we can just substitute those in. 2x is our A, and y squared is our B, and we can just substitute them in all the way down this polynomial. Just managed to fit all those in with this big handwriting here. And so we're just plugging in our A's and our B's, and from there it's simplifying, and then we can have this whole expansion instead of trying to do just a million distributive properties, and that's really why it's helpful. So the first one, we've got 2x to the 4th, so 16x to the 4th. Here it comes 4 times 8x cubed y squared, so 16x to the 4th plus 32x cubed y squared. And I'm going to do the rest of them. You can follow along, try on your own, and check your answers. All right, so Pascal's triangle helps us do this full expansion of what this would have been here without as much distribution. And we can go through it relatively quickly. But this Pascal's triangle really only is helpful up to the first couple numbers. Eventually this triangle just gets so huge you wouldn't want to do it this way, such as our next one to the 30th. And that's where you can arrive at a formula for the binomial theorem. And with the questions where you want to use the formula are ones where it's just asking for a single degree. If it's something like this, where it's asking for the whole thing to be expanded, it's probably going to be a Pascal's triangle question. Though you can use the formula if you like. So here it's asking for the 10th degree term. And what this tells us is that every term of the expansion is a series where each term is n is constant, and we start at k equals 0, and we just keep changing these numbers to different k's. That's what our series notation is. This tells us that this is the variable, and we work our way along, where again, the a's are counting down, so this is n minus 0, n minus 1, n minus 2, that's getting smaller, and the b terms are counting up, 0, then 1, 2, 3, as k increases. So this formula just gives us the whole series. If I'm looking for one term, that's just this. And then the question is just, okay, what's the value of k? Because that's a single term. So if I'm looking at this formula here, I can say that, oh, that's our n. We've got our a and our b, just like we sort of separated out in the last example. And here they're asking for the 10th degree term. So remember, 10th degree means that we're looking for x to the 10th. But since this isn't just x, this is x to the 1/2, what that means is then we are looking for x to the 1/2 to some power. And since it's 10, that power is going to be 20, which then cancels out like this. So then 20, since is equal to n minus k, this formula here, because 20 is the power of a, since that's the power we want of this term, so then that's equal to there. And we end up with, since we know that n is 30, we can say, well, 20 is then equal to 30 minus k. K is equal to 10. So now we've got all of our variables to plug into our formula here. because we're just looking for the single term. So here I've got the formula all plugged in. With a numerator like 30, I'm definitely going to use my calculator, right? And so you can do that now, practice that, and you get an absurdly big number, which is why calculator's the way to go, right? We've got 30,045,015, right, as our factorial. Use your calculator. Then we have x to the 10th, just like we wanted here, and then finish up with 1 to the 10th, which is times 1, which doesn't actually make a difference in our final term. So the 10th degree term of this polynomial is 30,045,015 x to the 10th. Let me know if you have any questions about any of these things. You're not going to have notes for Thursday. You'll notice in the planner update. Please do that if you haven't already. You're going to be doing some Chapter 11 review problems. You'll have a little end of the week quiz, and then we'll go into practicing and preparing for the final. Have a wonderful day, and let me know if you have any questions by email in the comments or on Zoom.